Hi everyone, today I'm going to solve some exercises from your homework, exercises 10.1. Before starting solving exercises, I would like to have a review. Okay, let's have a look. Let's start with derivatives. Okay, we have a general power rule for x to the n. When we take the derivative of x to the n, you remember that n brings down as the coefficient of x and the power will be decreased by 1. N times x to the power n minus 1. Okay, let's have a sample for this. 2x cubed. When we have 2x cubed, again, we will apply the rule. 2 times 4, which is 3, and we decrease by 1. Accordingly, we get 6x to the power 2. Similarly, we are going to get the integral. Shortly, we could say that integral is antiderivative. It means we are going to have reverse operation, reverse process of taking derivatives. Okay, let's have a look. We have the general power rule, x to the power n dx. When we integrate the function, we get x to the power n plus 1. It means we increase the power of n, x by 1. We divide by the same number and we add by c. You remember that c is called as constant. We shouldn't forget that here, since we have denominator n plus 1, n cannot be minus 1. You can see that if n is minus 1, we can say it is x to the power n number divided by 0, which is meaningless. Okay, let's have a look. For example, let's have x to the power 5 dx. Let's apply the integral rule. We got x to the power 5 plus 1 over 5 plus 1 plus c. It means x to the 6 over 6 plus c. Okay, let us check, is it really true or not? What is the derivative of x to the 6? Okay, since we know that the integral and derivative are inverse operations, we can apply the rule reversely. X to the 6 has derivative 6 times x to the power 6 minus 1. We have already denominator 6. Here we got 6 are cancelled, x to the power 5. You see that we have the integral of x to the 5 is x to the 6 over 6. The integral of x to the 6 over 6 is x to the 5. Okay, let us start with the exercises. The first we are going to solve 1a. In the question, it is asked given dy over dx and it is asked y. So it is given the derivative of the function and we are going to find the original form, or we could say antiderivative. In 1a it is given 2x dx. You can see that number 2 is a coefficient and it doesn't matter our formula. 2 times we have the power of x is here 1, we add by 1, we divide by the same number. We add of course c. It means 2 times x to the 2 over 2 plus c. It means we have a cancellation here, x to the 2 plus c. Okay, let's go with the second exercise. 1b. Okay, in 1b, given again dy over dx, which is x to the power 2, the question is find y. So the derivative is given already. We are going to find the primitive of this function. So shortly we say that we are going to integrate x to the power 2. You remember in the previous question, again, we integrate the function. Here it is. Let's apply the rule. X to the power 2 plus 1 over 2 plus 1 plus c. It means x cubed over 3 plus c. Okay, let's have a look at the questions together. In the first question, 2x, we have x to the power 2 plus c. In this question, we have x cubed over 3. Okay, let's go. In 3a, we have 6x dx. We are going to find integral of 6x dx. So you remember that x has the power here 1, 6 is the coefficient. X to the power, we increase the power by 1 and we divide by the same number. It means 6 over 2, x to the power 2 plus c, and we get plus c. 6 over 2, we get 3, x to the power 2 plus c. What about 3b? Similarly, 3b, we are going to apply this sample for x plus 1 dx. In this, there are two terms, first term, second term. You can integrate each term separately or in one you can. It means 4, we have the power is here 1, 1 plus 1 over 1 plus 1 plus, okay, what function has derivative 1? We say it is x. X is a variable which has the power 1 plus c. If we simplify that here, x to the 2 over 2 plus x plus c. After cancellation, we get 2x to the 2 plus x plus c. Okay, the next question. The integral of 4x x to the power minus 1 over 2. In fact, it's exactly the same sample like the previous one, but we have a negative power. We should be careful when we are having operations. Okay, let's apply the rule. 4 is the coefficient, x to the power minus 1 over 2. We will add 1 to the power and divide by the same number. Accordingly, we got x to the power minus 1 over 2 plus 1, we get 1 over 2. And we have the denominator, of course, it will be the same, plus c. So, 4 divided by 1 over 2, x to the power 1 over 2 plus c. If we rearrange this, 4 divided by 1 over 2, which is 8, x to the power 1 over 2 plus c, or you can write 8 root of x plus c. Both are acceptable. 3d, the integral of 7 x to the power minus 8 dx. Okay, 7 is the coefficient, x to the power minus 8, we increase by 1, and we divide it, plus c. It means 7 times x to the power minus 8 plus 1, we get minus 7 over minus 7 plus c. We have a cancellation here, of course, here it is. We get minus is a coefficient here, x to the power minus 7 plus c, or minus 1 over x to the 7 plus c. Again, they are both acceptable. The next question. In this question, we have x plus 4 squared dx. Okay, we have a power, but in fact, when we have a look, we have an inner function. So it's a kind of composite function. In that moment, we are going to have expansion. We need to expand x plus 4 to the power 2. When we expand that, we get x to the 2, 8x plus 16 dx. So 1, 2, 3 terms we can integrate separately or in one all. X cubed over 3, 8x squared over 2 plus 16 has the integral 16x. Of course, we do not forget to add c. If we rearrange this, plus we have a cancellation here for x squared plus 16x plus. That's all. Okay, in the next question. 3f. The integral of 4x over, we get 3. Yeah. Again, we have 4 over 3 here. The coefficient. So I can rewrite this 4 over 3 x to the power minus 4 over 3. When we integrate, we will increase by 1 and we divide it. Plus of course, c. So let's rearrange this. we get x to the power minus 4 over 3 plus 1, we get minus 1 over 3, minus 1 over 3 plus c. Okay, let's rearrange this. We got here 3 times minus 1 over 3, we got 1. We can have a cancellation here. Minus is in the denominator. We have the number 4. Minus 4 x to the power minus 1 over 3 plus c. You can let the question such that, or we can rearrange such that minus 4 x to the power minus 1 over 3 can be written x to the power 1 over 3 plus c, or we can continue one more step here. X to the power minus 1 over 3 can be written as root of x with the index, of course, 3 plus c. The next question. Three g. Okay, 9 minus 6x dx. We have two terms. We are going to integrate each of terms separately. 9, the integral of 9, we can say 9x minus 6 x to the power 2 over 2. You know that we have number 1, we increase by 1 and divide by the same number. So we get 9x minus, we have a cancellation here, 3 x to the power 2, of course, plus c. Okay, the next question. Three h, the integral of 2x plus 5x cubed over x dx. In this we have a division quotient form. So what we do? Okay, you know that when we have a division form, first we can write them what in partial fraction. What it means. So let's rewrite this. We integrate 2x over x plus 5x cubed over x dx. You see that we have the first and second term separately. So we easily can take integral of each term. Okay, let me simplify 2x over x, which is 2, plus 5x to the 2 dx. Okay, now we will start integrating integral of 2. We said 2x plus 5 x cubed over 3 plus c. Okay, one more sample. It is additional. 3i. The integral of 1 minus, here it is. Okay. In this question, you see that we have multiplication. We don't have a special formula to integrate products or quotients. That's the reason we will try to write in similar cases. So if we expand, if we distribute the parentheses, we get 2x minus 2x to the power 3 dx. So let's integrate separately. Minus 2x to the 4 over 4 plus c. So after cancellation, we get x to the power 2, x to the 4 over 2 plus c. For today, that's enough.